I want to be sure that you understand that I have a database for the class, and in order to give you grades and anything, I have to get you into the database. I don't count on the registrar's information because people don't show up, or people come and aren't registered and so forth. So basically what I go by is when you send me an email with your address, I put you in the database because I know you're a real person, and so I can actually assume that you're here. So you have to do that as soon as possible so I can get the database up and running. Some people, a couple of people had a problem with it, and actually I think just 3 people, and they were different problems, so I'll tell you what they are so you'll know in case you run up against them. The first one is when you create the database, you go to AltaVista, en.altavista.org, and you go through the procedure that I have a video for, how to create your web page host site. What happens is they give you a form, and when you fill in the form, you have to be careful that you do it exactly the way that I showed you on the video, because there are 2 buttons in particular. One of them is if you want to get a newsletter from them, and the other one is if you want to let them advertise on your site. Both of those are, well, the newsletter one's not so bad, but the advertising on your site is very bad, because here's what they do. When you have a web page, they take your web page and they incorporate more code into it. That's their advertising. That's how it's done. So the problem with that is this is a coding class, and they are actually subverting that by putting code on top of your code, and it causes quite a lot of problems. So we don't want that to happen. So when you start off, be sure that you do not press I agree to either of those 2 things, the newsletter or the unless you want to get the newsletter. So the point is that if you follow the instructions exactly, you'll see you can't get down that track. If you go down the wrong track, here's the problem with it. They won't let you out. There's no way to get out of it after that. You're locked in. They put a cookie on you, and no matter what you try to do, you try to make a new site, you try to do anything, and it just ignores you, and it says, it brings you right back to your old site again and causes trouble. So the only way to get out of it is you have to go to Gmail and create a fake account, just a temporary account, just with a different name to it. And then, it's not fake, it's just a different one. And then go on to AltaVista and use that new address. And when you do it, be sure that you don't click I agree to either of those 2 things. Probably nobody in here did that. Maybe it's just people online, but I'm speaking for them too. So that was a problem. A second problem was when people wanted to run their stuff, they actually got the information up onto the web, but they didn't know how to run it. Okay. What I did was I made an extra series of pictures of what you should see, step by step, what you should see when you're in there. In other words, how to get one of your programs up to the web. It shows you step by step how to do that. Okay. Basically, each one of those JPEGs show you exactly what step you're at, and they should always be the same. The only exception to that is, and kind of erratically, and I'm not sure why they do this, but occasionally that company throws in a different window that you don't normally see, a different window. So what it says is it has 3 different choices. The left one is you actually want to go to manage your site. That's what you want to do. Don't click on the other 2, the blue one or the one next to it. Just, I'll look at your direction. Click on the left one. Be sure that left one is clicked on, because you want to go to upload your stuff. And that'll bring you back into line with uploading. But if you click on either of the other 2, it goes to WordPress, and it starts giving you software that you don't want. Again, it's going to subvert what you're trying to do. You're trying to write a program, and they want to write it for you. That's a big problem. So those are the 2 problems I saw, the 2 issues I saw. And as I say, the one where you're going to get to your site is very clear. Just follow the pictures, and you'll see exactly what you should do and what you should get. The first problem I said, when you said I agree instead of I don't agree, that's a different problem, because now you have to create another website, another Gmail website, just to get onto AltaVista. So they won't stop you from doing it. If you have the same Gmail address, or they will say, oh, we can't let you on because you've already got an account or something like that. They don't care if you have multiple accounts, by the way. That's not a problem. But if you try to get multiple accounts with the same email address, that seems to not work with their system. And typical of these companies, you can never get a hold of them. I've tried 3 or 4 times to try to get a hold of them to tell them there's a problem there, but naturally, you can't get through their barriers. So I've never been able to get anything done. And that's it. That's it for that stuff. Today, what I'd like to do is talk more about the web page, and particularly about pictures, putting pictures on your web page. It's one of the things everybody does. We're going to put pictures, videos, sound, 3D graphics. We're going to put a lot of stuff on it. It's really interesting as we go along. But I think one step at a time is good. And another thing, if you guys have had HTML code a course in this, you're going to see the same stuff you've seen before in a very simplified version of it. Because this isn't an HTML course. We only use it as a vehicle to get to what we want to do. It's just getting into it. We have to get on the web, so we have to speak HTML just to get on the web. There are 3 components to what I have to teach, and I'll show you what they are. The first one is HTML code. Okay, that's the stuff we started with already. You've already written an HTML program. Okay, and there's another thing called CSS, which I'm going to do a little bit of today. It's called cascading style sheets. We just call it style sheets for short, just style sheet. It's a style, okay? That's another one. And the last thing we're going to do is JavaScript. And another thing I want to mention to you right now is that JavaScript is not Java. They're not related directly. All languages sort of look like each other, but Java and JavaScript are completely different. And in fact, I can tell you the difference between them right now. But let me go through these first of all. This right here is the deal with the chevrons. It just tells you what's going to be on your page, okay, and some information about it. What this stuff does right here is a little bit different. CSS, the style sheet, was invented because when they first invented the World Wide Web, they had HTML code, and HTML code had a lot of problems with it. It was inconsistent because it tried to do this and that was in the way, and basically when they started adding to it, they were adding to it helter-skelter, and they realized, oh, we have quite a mess going on here. So what we're going to do is we're going to change strategies. They fell back to just the main HTML code as HTML instructions, the tags we're going to be using. And then what they did is they invented this new thing, the style sheet, and that's incorporated into the HTML. So in other words, you have HTML, and you can put style into it. So for example, if you have a bunch of words, the style will tell you how big to make the letters, what characters to make the letters, whether they're italics or not. It can tell you all kinds of things. In other words, the style sheet, color, anything. The style sheet actually allows you to get more detailed descriptions of what the words you're using are going to look like. Okay, so that's what the style does. So basically, this is still what we're doing. That right there is just a little refinement to help us get prettier pages. That's the idea, you get a prettier page. This guy right here is totally different. What JavaScript does is, suppose you want to do some arithmetic calculations. You want to do something very exotic. You want to have your computer talk to you. You want it to talk to it. You want to do things that are not what it was originally intended to have on web pages, which is basically words and pictures. So what JavaScript does for you is it allows you to get great control over those other things, over all of the oddities that we're going to be engaging in. That's where we're going. These 2 guys here just help us get to that. That's the thing right there that's going to make all the difference. And so today I'm not going to talk about that. I'm going to talk more about these 2 guys. But because the stuff that we use in here comes from here. The JavaScript does do mechanical stuff and everything like that. But here's what your web page always does. Here's the nature of a web page, okay? The nature of the web page is it comes up and it shows you something, whatever it shows you, something. And then you can talk to it. It can talk to you. It's a communication deal. You talk to it, it talks to you. You say add 101, it adds 101 for you, it gives you the answer, it talks back to you. So in other words, you send stuff to the web page by communicating with it with your mouse, your keyboard, your voice, whatever, and it goes into the computer. JavaScript picks it up, does calculations, mumbo jumbo, whatever it does, and it starts sending answers back to you. It gives you the answers and tells you what you want to know. So in other words, what you see here is the front end. This is what the person sees when they're looking at the web page. What they don't see is this. They don't see that, and they don't really see that, and they don't see any of those things. All they see is the result of that. This creates the pictures and the words, whatever they are. This refines them so that they're the right kind of type and font and whatever they are. That refines it, makes it prettier. And this thing right here takes information that you're giving it, does something with it, and gives you an answer. That's how we use it. That's what our purpose is with JavaScript, okay? And those of you that have had HTML, when you see what this does, you'll be quite impressed. I mean, it's a very powerful language. In fact, the thing is, that's powerful. What does that mean? It means that it can do things that you can't even imagine. In fact, it hasn't anywhere near reached its full use yet. It's just coming in now. Here's the reason why. They added JavaScript just a few years ago, and it didn't have much power. The reason why it didn't have any power is because the computers were too slow. The net was too slow. We didn't have these, broadband things that were coming into everybody's house now. What we had was telephones. You didn't have very much. You had very few things. So therefore, JavaScript, even though it's very strong, a very good language, it does all kinds of stuff, the net couldn't work fast enough to appreciate that. So for example, you could draw a picture, but the picture would go bloop, and then the next frame would go bloop, and it would go bloop. It would be very, very slow. Everything would be very slow. Now, game people used a different strategy entirely. Here's how games are done. They're done in a totally different way. In a game, the program itself is actually in your machine. Like WoW is in your machine. The program's right there, acting at the speed of your machine, which is enormously fast. And all it sends back and forth is just a little piece of data now and then. Where are you now? Which way are you looking? So it's just sending little tiny bits of data. Any internet wire can handle that. So the thing was, the game people made it look like the world was already at the stage where it could do all kinds of stuff, but it wasn't. What it meant was that in your machine you had this thing that was drawing pictures and doing all that stuff, and all you're exchanging with the guy you're playing with is one little piece of information. I hit you, you hit me, and so forth. This thing here is a totally different universe. What this thing does is this thing calls on the web for instructions to do things in real time, and it actually can now produce movies, or it can render things moving around, stuff moving around. It still can't do enormous amounts of stuff, but it can do move boxes and spheres and make planets rotate. It can do all that stuff. It might not be able to get a gang of 15 people running down the street with all different kind of clothes on and everything. If they all look exactly the same, it can do it. But if they all look different, it has a hard time doing it. So this thing right here is our new opportunity to put graphics on the web differently than it's ever been done before. The disadvantage of WoW and those things is you have to download a program. And once that program's in your machine, you're compromised. You don't know what that program's going to do. In other words, it's 6 miles of code, and in here someplace there could be one little glitch that says, if you type in your name as Sam Smith, blank out the screen. You can do anything. You don't know what it's going to do because it's a real, honest-to-goodness program in your computer. These guys are not programs. They look like programs. We write them like programs. What your computer does is it looks at every line and it says, what do they want to do? They want to do this, so I'll do that. It looks at the next line and says, what do you want to do? I'll do that. So in other words, it reads the code that you write and does what you told it to do. The big advantage there is there's no place for viruses. There's no place for it to sneak up on you. Because when your computer browser, the browser is what does it, by the way, when the browser reads the JavaScript, it only has one way you can read it. If it sees something funny, it doesn't deal with it. So therefore, it prevents you from getting bad. Now, I have to tell you that just like hackers are very clever, they find ways of doing everything. There's always some way in. And they have found ways to cause troubles with JavaScript. And the way they cause it is when you download a program with someone's JavaScript that you don't even know who it is, that JavaScript could be doing stuff to you. Because it may be a bad program. It may have some stuff in it. I mean, if you read it, if you could read the program, you could say, oh, they're taking the IP address and they're doing this and they're doing that. You could see them doing it. But most people don't look. I mean, when you look at a web page, you look at the window that they give you. You don't look behind the scenes to see what's there. You can look behind the scenes, and we're going to have to do that. In other words, we're going to have to look at our program, these programs here. We see what it runs, and then we can just right-click and say, show us the source, and we'll be able to see the code that actually makes that exist right there. You can do that. But temporarily, the point I'm trying to make is that this can be dangerous if you download someone's code, you don't know who they are, and they do something weird to you. If it's just, for example, your bank uses JavaScript probably, everybody's using it now because it's the up-and-coming language for the internet, because it's relatively safe. It's very, very fast now. It used to be slow, now it's very fast. It's been written quite well, and it can do all kinds of things. It's got a lot of variety of things it can do. So that right there, we're going to tippy-toe into JavaScript. We're not going to write the complete language because it's like any language, it's big and complicated. But we're going to write little programs in it. The little programs that will do a lot. You'll see how much it can do with just a few lines of code. And so that's the endpoint right there. These guys right here, which I'm going to deal with today a little bit, are handy for us because they're going to make a web page. It's got to have some decency. I mean, it's got to have pictures. It's got to have stuff. So in order for us to get stuff on the screen, you got to have the basics. You got to know how to do that. Okay. First, what I normally do is I do this first because it isn't something that I'm ever going to test you on. But what it does is it gives me the opportunity to show you one place behind the scenes that's kind of technical, but we actually have to use the stuff. It's not that I'm going to test you on it, but you're going to have to use it. It's information that you'll have to use. Okay. And sometimes, like, when you have a telephone, you don't care what the circuitry in a telephone does. Nobody cares about that. You just care that when you press this number, you get the wrong person every time, and you wonder why. The question is, or this way, okay. The thing is that with when you're writing code, what you want to do is you want to like so. When you write code, blah, 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 some of that code is going to put words on the screen. Other code is going to put a picture on the screen. Okay? And those pictures, what are they like? What pictures are like is like pictures there you see on the net. They're just pictures, that's all, they're pictures. But pictures have a format. They have a specific way that they're made. They're not just normal pictures. If you try to send a normal picture through the internet with all of its details, every little pixel, the right color in the picture, it would slow everything down. A big picture, knowing all the details, would slow everything down. So what they do is they have a format called JPEG picture. So you have a picture and it's in JPEG format. What that means is it could be a giant picture, doesn't make any difference. But what they've done is they've applied this program to it, and it's taken that picture and it's squeezed the amount of data that it takes down very small. The picture's just as big as it was, but the data is very small. So in other words, they can transmit this huge picture over the web by just transmitting a little bit of data. Then when it gets to the other end, it expands it again. So it's big like it was before. The trouble is, this is called the lossy procedure. In other words, the original picture that you took with your camera, with your cell phone, has got all the details, it's got all that marvelous stuff in it. But once you reduce it in size through JPEG, when you look at this picture on the screen, it looks a little bit fuzzy. You can't actually detect it most of the time. But if you pull the picture up big enough, you'll be able to detect it. When they're small, they all look almost exactly the same. Our eyes aren't perceptive enough to actually see the difference. Okay. So what happens is they squeeze these things down, and you can alter how much you squeeze them down. You can tell JPEG, squeeze it a lot or squeeze it a little. If it makes it very, very tiny, then when it blows up, you're going to see all kinds of miscoloring. You're going to see a big mess on your hands. Okay. If you squeeze it down just a little bit, it's still pretty big to go through the web. So what you have to do is you have to figure out how much to squeeze it down. Well, it turns out the programs come with built-in size parameters. They're built in. You can change them. You can say, I want to squeeze it down more, or I can squeeze it down less to make the picture better. But it comes pretty much with the optimal size. The size that will squeeze it enough so that you save enough transmission time, but not so much that you're going to see the difference. Okay, it finds that optimal area. So that pretty much takes care of it. These things right here, these JPEG pictures, are regular photographs, except they've been shrunk. They're smaller in their data, the amount of data they have. Okay. Now, the thing is that I'm going to start off with, where would you get a picture? Where do you get pictures to put on your website? Well, you get your own pictures. You can scan them in, all that stuff. Take them on your cell phone, put them on the computer, on the cell phone. You can do that, or you can get pictures from the web. Normally, If a picture on the web says it's copyrighted, don't use this, and you can't use it, okay? If it doesn't say that, because you're in school, and these are classes, and this is an educational process, we have the ability, which other people don't have, to actually use, borrow copyrighted stuff, pieces of it, to put in our files, because we're learning how to do it. They allow schools to do that. Okay, and I've heard from somebody who's kind of an expert on campus that there has never been a successful suit against any school for using things like that. So I'm presuming
imagery.
Images, yes, images. As long as they don't say "do not copy copyrighted." If they actually explicitly say "do not copy copyrighted," then you might have a fight with them. But I wouldn't use it anyway. If they're that persnickety, I wouldn't use them.
Well, usually don't they argue that it's like, this is for educational purposes only, like it's one thing if you're trying to make like a financial gain off of it, or pass it on as your own, which is plagiarism at that point.
Yeah, are you a lawyer?
No, but
no.
I've just seen the disclaimer of like, this is for educational use.
Right. Well, it doesn't have to be for education. Yeah, for educational use, as I say, these have gone to court many times, but they have never won a case. So obviously, it's not very strong. Be careful. Be careful when you do anything on the web with people's, especially with some, like YouTube, for example. YouTube is very touchy. Okay, they're very touchy, but they don't sue you or anything. They basically say stop using our stuff. Stop using somebody's stuff. They'll just tell you, or tell the school to tell you to stop. But that's usually in the realm of people's music. Music is a big one. That's the one that. These music guys, they want anybody to play their music, and they do all of it. You can play part of their music because we have the right to take a piece of it and use it for various things. There's court cases that back that. But here's what I would suggest to you when you're getting pictures. You can go on the web and get them. You can take them, and if they don't say copyright, do not copy, or any of that kind of stuff, you can use them in your web pages. Okay, just as long as you're using them here at school in their class, it's classroom. That's safe. Don't sell anything, or don't do anything that would actually jeopardize your position as a student. That's all. So, how do you get pictures? Very simple. Suppose you want a picture of a waterfall. You go on Google, you type in waterfall, you type it right into the Google, top line, and what will happen is they'll come up with Google, find all these pages with waterfalls. Just click on images, and all the images will come up. Of all the waterfalls. There are more waterfalls than you could ever dream of. They're all over the place, different pictures. Find the one you like, click on it, and when you click on it, it'll open up a box, and it will show that picture and a bunch of other pictures. And you can choose any of the ones that you have, and you can choose any of these you want. If you want this picture, it says show picture, show image, and what will happen, you click show image, it'll show it all by itself. Then you do like you would save anything. You right-click on it and say, you can either say save as or copy the clipboard. You can do it any way you want. You just right-click on it, and that's what you get. So that image, then you can save it, and you'll have it. Okay. Now, that's stage one. You've got a picture of some kind, or you took it from your camera, and however you got your picture in. The next question is: sometimes you want to take your pictures and you want to make them smaller or bigger. You want to fix something. You can take colors and you can eliminate colors so they're transparent. You can do all kinds of stuff with these. So what you have to do is you have to have a program that allows you to manipulate these pictures, okay? So I found a free program online, and at our site is it's called XNView, V-I-E-W. It's a French guy. He's been doing it for years. His program is excellent. It does far more than you'll ever need. But what XNView does is it allows you to bring in a picture. You can change its format. You can't just, in a program like if you have a picture, .jpg, and you want to change it to a different format besides JPEG, you can't just erase that and make it different. You can't do that. It doesn't allow you to do it. What you have to do is you have to bring it into a program like this XNView, and then you have to save it as, save as, and then you select a different format. You say, I want to save this as a different format, okay? And one of the most common formats we use is called PNG. PNG and JPEG, those are the two we use most. GIF is another one, but these are the ones we're really using quite a bit of, JPEG. So now that you have a picture, you can have it in
PDF.
You can have it in what?
What about like a PDF? Maybe like, can you like convert like a PDF to a JPEG using one of these?
A PDF, did you say?
Yeah, because typically when you like scan something on paper, it saves as a PDF file. But I feel like before I have seen it done, like
it doesn't save as a PDF file.
Like when you use like a scanner.
Yeah, it saves
and
it
like
as a
email
JPEG.
It to yourself.
It saves it as JPEG.
No, I've seen it save as like a PDF.
You have. Okay.
But I feel like there's a way to like convert with using whatever, like I want it as a JPEG image, not as a PDF.
The easiest way to get out of PDF, I think, the easiest way to get out, if you have full control over your PDF, you can do it. In other words, if you own the program and you're not just using it over there in the lab or whatever,
right.
What you do is very simple. You get the thing up on the screen and you hit print screen. In other words, you take a picture of the screen, take a picture of that, and then from the clipboard, put it away and save it. It'll save it that way, yeah. That's the best way to do it. But anyway, in this case right here, we're only going to be dealing with these two guys right here, okay? And the JPEG is the one that squeezes it down. Ping is an entirely different animal. What Ping does, it does many more things, as I say, more things than you'd ever want to do. But one of the things it does, which we really like, is you can create transparency in it, transparencies. So for example, suppose you had a mountain scene, okay? You have a picture of JPEG, it's a mountain scene, like so, and you want to put somebody in front of it. Well, the trouble is, the only picture you have of somebody, they're in an ocean scene. You want to get rid of all the ocean, you want to get rid of everything around them, so it's just them, so you can then take them and you can put them in front of the mountains, like so. So in other words, what you have to do is you have to get rid of the ocean so you can take just them and put them in front of the mountains. Well, a Ping file, you can erase all of these guys right here, all this stuff over here. You can do that in ExinView. So here's what you do. You get the picture of the guy with the lake or the river or whatever's behind him. You bring him into ExinView. There's a way of doing it, and I'll show you how to do that. You can erase the background behind the guy. And then you can save him as a Ping file. And then you can put him in front of the mountains, and he'll block out the mountains, but there's nothing around him. It's transparent. So therefore, he will now be put into a different scene. Okay. Now these little tricks that we'll have to be doing these things as we go along. I'm not teaching you how to do it right now. I'm just saying this is the kind of stuff we'll be kind of dealing with. So ExinView is the way to do that because it gets us into the tools necessary to make things transparent and to deal with it. Okay, pardon me. Next question. If you look at your screen, it's pixels. It's a bunch of pixels. Basically all it is RGB, red, green, and blue colored dots. That's all it really is. Nothing else there. Now you may wonder why they make all of the colors as blends of red, green, and blue. And the reason why they do that is because the human eye, that's the only colors we can see, is red, green, and blue. We can't see. All the in-between colors are simply a blend of those three. That's why it works, because we can blend those things and we see different colors in between, various like pinks and so forth. So the question is, they looked at that and they said, okay, we can only see red, green, and blue. So they figured it out. They said, well, if we make a dot, a tiny little dot, called a pixel, and we break it up into three parts like this. This is very tiny, it's a very tiny dot. And if they put red, green, and blue like that, if they put red here, green here, and blue there, this is on this teeny little dot, and they vary the amount of red, green, and blue, they vary how much is there. So for example, supposing there's only this much red, and this much green, and this much blue. See, it's a combination of these three amounts of red, green, and blue. What that does to our eyes, it causes us to see a different color, combination of the colors. Okay, and that's how it works. Basically what they do is every pixel on the screen has red, green, and blue. And they apply electricity to these little decision-making circuits. And what they do is they say, well, if you apply a lot more electricity, you get it, it's redder. Apply less electricity, it's less red, it's more white. And the same with the green, and the same with blue. So they have three wires coming into every single pixel. It has three wires coming into it, the red, the green, and the blue. And what happens is they vary the amount of red, green, and blue. Therefore what they do is they make a whole screen of these little dots with varying amounts of red, green, and blue in them, and it creates an image. You can draw a picture like that. It's that simple. Okay? So that's how it's created. Now, that sounds like a technicality, but in fact, we're going to have to use that right away. I'm going to use it today. We have to know how that works in order to understand what we're going to do. Suppose you have a screen. Let's write a program. So let me write this program right here. I'll write it over here.
So, you know how you have like the head and then the slash head, which indicates the end of that? Is there ever anything between the head and the end of the head, or is it just a placeholder? I don't remember.
We're going to be lots of stuff in there.
Okay.
Yeah, that's the JavaScript area. That's what we work with JavaScript. Okay, so here's we have this hello here. If you guys look at that, can you tell what this program does?
It says hello.
It says hello. What kind of color is the screen?
White.
It's white. It's always white unless you tell it different. It just comes in white automatically, which kind of makes sense. The letters come black automatically, so you can write on it, right? Okay, now, supposing you didn't want to have a white screen. You wanted the screen to be a different color. Okay? Here's what you could do. I'm going to introduce, this is the first instruction for CSS. This is the first style sheet, first style instruction. Okay? We're going to add this in. This HTML command right here for body, whatever we set up in there, whatever controls we set up for how we want things to look pretty, that within the body, it will do that. So if I say I want everything in the body to be red, it'll do that. If I want everything in the body to be large, it'll do that. Whatever instruction I put in here in CSS, in style, I can say I want this to impose on everything in the entire body. Okay? So here's what I'm going to do. When I write the body instruction, leave a space right here. Leave a space. And then write the word style. So, equals, quote. What that does is it changes the background color behind all the letters that you're typing. It changes the background color to a different color. Instead of white, it will now put in yellow. You could put blue in here, or red, or green, or pink. There's a whole bunch of words you can put in. Okay? They did that because people didn't want to learn the coding for each color. Because you can't learn the coding. There's so much coding, I'm going to show you why in a couple minutes. There's so much coding, you cannot learn it. There's no way to learn it. So what they did is, they had a few common English words that you can use to set up color, but that's the only colors you can get. Maybe there's a couple of dozen, I'm not sure. They've probably refined it quite a bit. There's quite a few, and most things you can see. You can put aqua, you can put kind of color words, and they show up. Now, I want you to know one specific thing. I'm going to add a semicolon. That's not necessary at the end. But it is necessary at the end of some of these things. Let me show you what's going to go on here. First of all, you have a space. You have the word style, equals. You've got to have a quote mark. And then this written exactly as is, with no spaces in this whatsoever. Do not leave any spaces. You say background, hyphen, color, colon. That's a colon. It's not an equal sign, it's a colon. Okay? Then you write the color, whatever you want. And a semicolon says that instruction is ended. So there's an instruction right here. It goes from here to here. It says, I want to make the black background color of my web page yellow. And that's it. Then you have to have a quote, and you have to finish the chevron. That's it. So that style has been put into the body, so everything in the body is going to hear that. It sees the background color, makes it yellow, puts the black hello on top of it, and that's it. Done. Very simple. Okay? that's a CSS command. That's what it looks like. Supposing you want the font to be, let me see, I want to do these in order because I actually did them before in order. Supposing you want the font to be, if you run this program, let me run this program first of all. When I run the program, what it does is it makes the background yellow and it puts hello right here. Puts it on the left side of the screen because that's the default. The default's always left, just like you're writing, of course. If you were in Israel, it would put it on the right. But then you'd have to know how to write Israeli, which is hard. So basically, what we want to do is, supposing I want the hello to be right in the middle over here, instead of over here. I want to put it there, okay? I want to be sure this is the second program before I do this, because I want to get out of sequence here. Okay, it is. There it is. Text align center. And when you run this program, it'll make the background yellow, and whatever text you write will be put right in the middle. Kind of cool. It centers the text, okay? Question?
Do you have to have a space between the semicolon and the text?
You have, after this quote, there are no spaces at all.
Okay.
Right, that's not a space. It looks like one, doesn't it? Yeah, there's no spaces. Put no spaces in between these quotes. Always lock them tight, and do that because you're going to find out that some places it might ignore the space, but another place it might not like it, so you've got to be really careful. The ideal thing is just squeeze it all down so that there's no spaces.
And none of this is case sensitive, correct? It
I
can be either
would,
stick with one or the other,
let's do it this way. Everybody write in lowercase unless we decide otherwise, because there are some times when you have to be careful when you write up in lowercase. Tell you the truth, I'm not even sure if this is case sensitive or not. I'm not sure if it is. I've never written uppercase in here. You can try it though. Let me know. Okay, so what we have now is we have two instructions. One instruction says background color is yellow. The second instruction says text align center. So there's what we have is hello in the middle with a yellow background. As I say, you can use different colors here. But the question is, well, let's keep going. I want to be sure I get all these things out of the way before I go any further. Next thing I want to do, supposing I want to make a page look like this. I wanted the thing to say hello, space, 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 bye, like that. I want a big bunch of spaces in there, okay? Well, I'm not going to say text align center. I'm going to get rid of this because I don't want that anymore. So I'll leave it yellow, that won't make any difference. So we have a yellow page, and instead of saying hello, I hit the space bar, and write bye over here.
So there you can have some, you do not need to use any
Be
kind
cool,
of
I'm trying to
symbols.
teach this, be cool. Be cool. Okay, so basically what you want to do is when you write this thing, you have hit a bunch of spaces, and you expect to see, when you run this, and you expect to see this right here, but you don't see that. What you're going to see is this right here. There's going to be one space there. And here's the reason why. Because it doesn't recognize more than one space. It goes back, it's a historical thing, it goes back to the beginning of HTML. Basically, they invented a way of putting a space in it. You have to actually type something to make a space. You have to type something in here that HTML sees, but your people that are reading it don't see. It's a funny character, okay? And the way they represent that funny character is with 4 letters and an ampersand. See if I'm in the right order here. I want to be sure I'm still in the right place. Okay. Am I in the right place? Yeah, okay. I'll keep my programs here. So what you do is you write hello. Suppose you want 5 spaces in there. You write an ampersand, so I've got to be careful here. Ampersand, looks something like that. Does that look like an ampersand to you guys? That right there, in BSP, small letters, all lowercase. I write in uppercase, by the way, but that's only because it's easy to read. My lowercase writing is not much good. that creates a space. You have to do another one for another space, and another one. In other words, every space that you want, you have to write that ampersand ABS. It's weird, isn't it? It's one of those things, it's left over. It's an artifact of how it began, and we're still stuck with it to this day. So now if you do that, you put a bunch of these in here, then it will space. Those things will become spaces. Every one of those things will become a space, and you get what you want right here. Now, here's the problem with it. There is a character that represents it. That's a bunch of characters. There is a character that represents that, but you can't type it. See, so it's one of the weirdo characters, yeah.
What exactly does NBS?
I wish I knew. I imagine it means space. I don't know what that means. I have no idea. It's so old I don't even remember. I've used it for 1,000 years. Yeah.
The first character of that, is that the and symbol?
What?
Or
Well, I'm sorry, you have to...
before the N, the first character.
There's an ampersand.
So is that the and symbol? I'm a little bit confused. Okay.
Ampersand is an and symbol, yeah.
Okay.
Yeah, it's not the G cliff, which it kind of looks like, I know. Does that answer your question? Okay. Okay, so now what you have now is an ability, this is what you have so far. If you want to make spaces, if you wanted to have a bunch of spaces between hello and goodbye, if you want by down here, some distance, like suppose you want several spaces down, what you would do is something quite different. You'd write this. BR for a break, another BR for another break, another BR for another break, and it would make, you'd see that. That's what it would do, it would go down 3 spaces. By the way, I could hit return here. It doesn't make any difference. For example, if I get this written like this, I could also have it written like this. Hello. Any combination works. I could have BR here, and then the other 2 BRs here. Anywhere, it doesn't make any difference. Because what it does is it reads one after the other. It doesn't care where they are. In other words, it doesn't know when a line feed comes. It doesn't see a line feed. So it just keeps reading right along. So it reads hello, break, 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 bye. Hello, break, 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 bye. It's going to do the same thing. It doesn't care about the fact that you put line feeds in there. So that's the one thing you got to get used to is this thing here tells this to return. Without that BR, you don't get that. You can do it with other things. They have paragraphs. They have various other ways of doing it, but we're doing it with a BR. That's because you want to break the line. And that's kind of, I think I pretty well covered what I wanted to talk about here. Now I want to get down to some other details. Yeah. No, one more thing. I got one more thing to do. I want to get a picture in here. Supposing what I want to do is, I want the thing to say hello. And I want to put a picture in here, right here. And suppose I have a picture, and it's a picture, the guy's name is Sam.jpg. Sam.jpg, that's the picture I have. I click on it, I see Sam, he's there, okay? I want to put that picture on my page, under the word hello, okay? If I want that to be in the middle, what do I do here? Do you remember that? How would I get the hello in the middle? I haven't got it in the middle.
Text line center.
Yes. What did you say to say?
Text align center.
Did you say text? Center. Whoops. Center. Okay, now Sam, that'll put it in the middle. Okay, everything's in the middle, so hello will be in the middle. Now, where's Sam going to go? That's the question. Sam goes right here. So what happens is, what this does is that this produces that effect. Now, you got to be careful. I think you have to put a BR here to be certain. Whoops, put BR here, because otherwise you may find the word hello next to Sam over here. You don't want that. So what you do is you say, hello, BR, line break, and then Sam, and what will happen is the picture will come in just exactly like that. It'll show you exactly, it'll be in the middle because you told it to be in the middle. Question?
No.
So everything's in the middle because that's what you said, everything's centered, and that will do it. So that produces a yellow background. The text and the picture are both in the middle. Even though that says text align center, even pictures are considered text. They're put in the middle also. So everything goes to the center of the vertical center. And that's it. Okay? Image source equals a space right here. There would be a space here. Be careful of your spaces. That's very critical. There's no space here, no space, no spaces. When you hit these tags right, you have no spaces in them. They're locked tight. Okay? This one here has a space here because you're about to begin a new kind of command. So that has a space there. Okay? Does that all kind of make sense to you? So now you could put a picture there if you want, or you could put words on your page, whatever you want. Now I'd like to show you is a little bit more about the color, because we're going to have to, we always won't have the word yellow for a specific color we want. Sometimes you have to go online and say, I want a different color. If you type HTML, I want to interrupt this. When you say you're looking for something in HTML, always be sure to write HTML5, write the number 5 right next to it. Okay? Reason being that the biggest mistake they ever made was they don't require web pages to have dates on them. So before HTML5, there was another HTML which also has web pages which are still up, which don't work anymore. So in other words, you don't want to ask a question and get it wrong, an old answer that doesn't work anymore. So be sure you type, if you're going to look for something, be sure you type HTML5 in it, okay? Let me start this off. If you want colors in HTML5, you say, what are the HTML colors? HTML5 colors, that's all you have to do. It'll give you all these web pages. Just pick one, and it'll show you colors, and it'll show you what you have to type in. I'm going to show you how you type what you type in now. You know, I'm not crazy about teaching binary stuff, because it doesn't make a lot of sense on its own. But sometimes it helps lock together the whole scheme of the thing. Everything does begin in binary for computer geeks. If someone says that 1 plus 1 equals 10, you know they're a computer geek because of the fact that binary 2 is 10. that's what 2 is in binary. So basically what I want to show you is a teeny bit of binary, a little bit of what they call hexadecimal, and then we'll go right straight to color. I'm going to show you. This is all based on why I have to do this, and I'm going to show you how to when you look at your list of colors with those letters in them, so you'll understand what they're doing and what those letters actually mean to you. Okay, they mean something. To begin with, all colors are red, green, and blue. Red, green, and blue. And it's called R, G, B. And in memory, there's a thing called a byte. It's a memory location. It's called a byte. Okay. And the red, how much red you have is stored in the byte. It's somewhere between 0 and 255 possibilities. There are 256 possible reds you can have because it only has enough. It can only fit 256 possibilities. So therefore, you can have 256 shades of red. You can have 256 shades of green, because that has a byte also. And you can have 256 shades of blue, because that has a byte also. All of these guys, all three of these guys in memory, wherever they are, go on to one pixel. They're all talking to one pixel. This one colors this red part, this one colors the green part, and this colors the blue part. So however big this is, that's how red it is. However big this is, that's how green it is. And however big that is, that's how blue it is. And that's how it's done. So basically, that's how each pixel has to have that. Has to know how much red, green, and blue there is. Okay? So, the question is, how do you talk about how much blue and how much red and how much green there is? If you talk in binary, in ones and zeros, here's what it looks like. Red has 1, 2, 3, 4. 1, 2, 3, 4. It has 8 bits. There are 8 bits in there which represent all the combinations there are of red. You can have this one on and all the rest off. You can have this one on and all the rest off. You can have these two on and all the rest off. In other words, you can see it. You get all the possibilities of ones and zeros. You can turn them all, and it turns out there's 256 combinations in there of ones and zeros. For example, you might have a 0 here or a 0 here. You can have zeros and ones, all kinds of combinations. So these guys right here, these are called bytes, and these are called bits. These are the bits that fill it up. Now, I can write down the list of what bits and bytes are, but I don't think you really care about that. But here's what you do care about. All three of these guys have this. So this one here might have a 1111, 1001, might be a 0101, 0011 or something. You can have all these combinations, any combination. This one combination tells you how much red there is. This one tells you how much green there is. This one tells you how much blue there is. Okay? There are 0 to, sorry, I'm going to backtrack here a bit. From here to here, all you can get in is 1, 2, 4, 8. All you can get in is 16 combinations, just in those 4 right there. You only get 16 combinations. Because if you sat down and you figured out how many zeros and ones, you wrote every possible combination, you can only get 16 combinations. All zeros, all ones, and all the combinations. So that comes out to 16 combinations right there. This one over here comes out to 16 combinations also, because it's 4 bits, and the arrangements can be the same thing. You can have 16 or 16. Now you can see what happens. If you can have 16 in here, you can have any of these 16 here, which means the whole number is 16 times 16. That's the number you get, which happens to be 256. Right? That happens to be that. So that's the reason why these guys, because each one, by the way, each one of these guys right here, this is called a byte, and 4 of them is just called a nibble. They call them nibbles. So you get 2 nibbles in a byte, okay? And the byte represents 256 possibilities. There's 256, 256. What that means is that every color we see in a computer has 0 to 255 red, 0 to 255 green, and 0 to 255 blue. Some combination of those is what produces each dot we see, produces those combinations. Now, the question is, if I wanted to be able to say a 2-digit number that represents how much this is and how much this is, so I can figure out how much is in this byte, right? How much is in this byte. This one right here will go, this combination here goes from a 1, 2, 3, 4, 5, 6, 7, 8, sorry, it goes 0 included. 1, 2, 3, 4, 5, 7, 8, 9. And then we don't, 10's 2 digits, so you can't use 2 digits. And when you're trying to find out the base number, you need a single digit. So they chose to use A, B, C, D, E, and F. In other words, in this binary thing right here, instead of saying 101, 1101, 1011, or whatever, they use these numbers instead, which represent them. They represent the same thing. This is if they're all zeros, you get that. If just that one's on, you get that. If 2 of them are on, you get that. I mean, if that 0 is 1 and the other's a 0, you get that. So in other words, these guys right here represent all the combinations there are. That's them. That's all the combinations. There are no others. So what happens is, if you want to know what's in a byte, what you have to do is you have to look at this nibble and this nibble, and it tells you what's in the byte. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Let me show you what I mean. For example, supposing I said I have 0, 0, 0, 0, and 1, 1, 1, 1. Okay, 0, 0, 0, 0, I've got 0 in the byte, so that's 0. 1, 1, 1, 1 says I've filled up the byte entirely, so that's F. That's as high as I can go. They're all filled up, so I get F. So what's in that byte? 0F is in that byte. That's the hexadecimal way of saying that that's what the byte looks like. So the byte can have any combination. It could have 6 and B, for example. It could have C and 5. It can have any combinations of these letters and these numbers and these numbers right here. And that tells you how much there is in that byte, what color it is, how much red there is, pardon me, how much red there is. The same thing is true here. The same thing is true here. So here's what color actually looks like in HTML. When you ask what color you got, you have 6 numbers or letters, depending on how you look at it. You could have CD, 1A, B3, like that. Red, green, blue. These 2 guys represent which ones of these are on. These 2 guys represent which ones of these are on. These 2 guys represent which ones of these are on. These 3 numbers right here are what they normally call HTML color. Okay, hexadecimal color. Red, green, blue. This is the red part, 2 letters, the green part, the blue part. Okay, does that kind of make sense to you? I don't expect you to be able to do arithmetic like that, but the point is, get the idea that what we're saying is that when you have red, green, and blue, we have to have a simple way of saying all the 256 combinations of red, green, and blue. In order to do that, we've got it down to what we call these hexadecimal numbers, which express that for us. These 2 guys right here express how many of these 2 nibbles, how many bits are on. And that tells us how big the number is in this byte right here. And same here and same here. So, now it comes to you, you go on the web and you say, I would like to see some pretty green colors or colors. I want to see the colors so I can choose one for my web page. Now, in the previous example, what I said was background color I put yellow, right? Okay, but supposing you don't want the regular old yellow or pedestrian blue or something. You want some weird color. You want to get something that's really good, really weird. So what you do is you go on the web, you say HTML5 colors, what have you got? And it shows you charts, it shows you these charts. And it has numbers like these in them, that's what it has. Supposing you look at the colors and you see one, you say, oh, I like this color. And supposing it's this combination right here, that's the color you like. It shows you these letters right here. Here's how you change the yellow to that color. You get rid of the yellow, you put a pound sign here, and you put CD, capital, all caps, 1A. Be careful that you use numbers where they're supposed, that's not I, so 1A, and a B3. That's it. And so forth. That's it. That's how you do it. So what happens is now you have the ability to put any of the millions, 256 times 256 times 256 are the possible combinations of color that you can have. It's quite enormous. And it turns out that our eyes aren't good enough to see the gradations between those. If you change it, you can't see that. Your eyes can't see it very well. That's another thing that JPEG uses it reduces the numbers of colors that you actually have. But you don't notice it because you can't see the difference. And the reason why I can't see the difference, by the way, is a good reason for that. Supposing you look around at the colors you see in the room, and you see certain colors. But if I turn this off, you still know they're the same color. You don't see them the same, but you know they're the same color. So our eyes are, we allow our eyes to play tricks on us. We say, oh, it's just dark. We can understand that. So therefore, we go with it. We just accept colors that are not quite right to be right. That's all. This bulb right here is it's making a certain color. We may not like that color. So we may have a little, a less fluorescent light. That less fluorescent light will change the color of everything in the room. But you and I and everybody would still say, well, everything's the same color, even though it's not. It's completely different to us. Okay, so that's all there is to that. And the color thing is important because it comes up again. If you change the color of a background, like for example, suppose you made the background black, you want to make it all black, huh? What do you think the color for black would be? What would it look like if you had black? You sure? What?
Wouldn't it be that you have red, green, and blue make white? So couldn't you just have the absence of that because black is the absence of light?
Well, the screen would be blank. There'd be no color at all. Just be you'd see the screen. You'd see the gray screen. You got to have something coming. Some bits have to be lit. Think about it. When you turn the computer off, what color is it?
It's black.
Yeah. Well, it isn't black. It's like gray or something. It's like, well, yeah. The flat screens are black, right? They're black, right?
We're going back to days of CRT monitors.
Yeah, I go for both. Not anymore. Question?
Wouldn't it technically be straight zeros all across?
Yes. That makes sense? It's all Instead of, we think it would be all Fs or all zeros. Think about it. What is white light? It's a combination of what? All the three colors, right? So F would be white. 0, 0, 0, 0, 0, 0 would be black. Make sense? It's kind of weird. Actually, it is very strange. They have to, mathematically, it's very hard for them to deal with that too, by the way. Behind the scenes, these things look maybe, but they look hard enough. But behind the scenes, to make this actually happen in electronics is even much worse even. Very complicated. But you'll learn that because you'll make a page and you'll think you want it all black and you put down F, and all of a sudden you realize your page is not black after all. It didn't work out right. But that's true, that's the way it works. Okay, next question. What I'd like you to do is one other thing. I'm going to have you bring down one more program, free program. It's called Screencast-O-Matic. Screencast-O-Matic. I think it looks like that, something like that, but it's listed in the website. The website tells you how to do it. Screencast-O-Matic. If you, supposing you want to go to get a video off of YouTube, you want to get a waterfall video, okay? What Screencast-O-Matic does, it's a marvelous program, it's really nice, and it's free, it doesn't cost anything. What it does is, you go to YouTube, you find the video that you kind of like, you run Screencast-O-Matic, and it has a frame, you put that frame around it, like so, around the picture you want, and you make it run. It's got a little button up here that says run, you run it. And what it does is, as this video runs, Screencast is capturing it. It captures the video, okay? And when you say stop, like right there, you say stop, it will bring up a black screen, it'll say, what do you want to do? There's a little reel of film there, it's fake, just a film reel. You just click on that and it says you want to save it. And then what you do is you give it a name and save it, and it'll come up on your desktop. And it'll be a video. You'll capture that video on your desktop. Of all the programs I've ever seen that do that kind of stuff, this one is magnificent. This is a great program because it does two things for us at once. You can take your camera and you can run it in your computer and you can run Screencast over the picture as it runs. And what it does is it takes whatever it looks at. Not only does it capture it, but it puts it in web format, so that when you upload it to your website, it will run in real time, which it wouldn't otherwise. Normal MP4s, normal videos are so slow because there's so much data coming down that it doesn't work. But what this program Screencast does is it takes a picture of the video and converts it to this web version of MP4. And so when you run the thing, it runs perfectly fast, and it's got good sound, it's really good. Costs nothing. The only thing you have to put up with, if you don't pay for the thing, by the way, if you pay for it, it's like 20 bucks a year, or permanent, it's 20 bucks I think, or something like that. But basically, there's a little thing down here that says Screencast, a little ad in the corner, and that stays there all the time. Everything you have is going to have that ad in it. But other than that, it's actually quite a good program. It allows you to narrate. You can, for example, you can make a video. The videos that you see that I've narrated have been done with Screencast. I run Screencast, and while I'm doing stuff on the screen, I'm talking. I'm saying, do this, do that. Of course, it's at 3 o'clock in the morning. I don't know what I sound like, but basically, I'm doing all this stuff. And then when you get the video, what you get is the sound I'm making, plus the video. You can get the video sound, too. That will be there also. So in other words, you can have the video making noise, and you can be talking, and it picks it all up. It's quite nice. I'd like you to get that program because we'll be doing videos, and you have to have something in your machine to use. I don't know what the maximum amount of data they allow you to put on that website. I don't think there is a max because no one's ever reached it that I know of. But you probably don't want to jam it up with lots of videos. Videos are very, takes a lot of space. You don't want to put a lot of videos up there, but I've had people put 20 or 30 up there and they work fine, so they apparently have that particular of how much space you use. Well, that's it. I'm going to show a couple of videos now, just of a couple of things I think you can watch them at home if you want. They're already online. And just to cover material that's better seen than having me wave my arms about. And that's it. If you want to stay, you're fine. If you want to leave, you're fine too. But I'll be here for another half hour running these videos. Okay?